assignments. So the first one was identifying like terms. So for this one, are they alike? Yes, right? We have to drag all like terms into the box. So anything with an x squared in it, we're dragging into the box. Anything with a w and a z in it, we're dragging into the box. If they have, are these the same? No, because x is raised to the second and this x is not. Y is not, and this y is, so no. Anything with an x, you would drag into the box. Not x squared, though, that's raised to a different power, right? So that's how you identify like terms. Here, all the constants. So these should have been pretty simple. I would say that the other one was a little bit more challenging, the adding and subtracting polynomials, but this is what we just did, right? They lined them up nicely for you. 5 plus 10 is 15. Negative 9 plus 3 is negative 6. Negative 2 plus 7 is 5. Positive 5. Okay? They lined them up nicely. 4 minus 3 is 1. So we're looking for just an x squared. 6 plus 9. And then bring down your negative 1. Question. All right. Oh, so let's skip these. These ones were a little bit trickier because you have to take the opposite of it, right? So this is really 6 plus 9. This is really negative 5 plus 4. This is really 5 plus 1. Oh, no, 5 minus 1. What was nice is they didn't even give you the other option. You had to take the opposite of these because there's a negative in front of it. Remember when we wrote these, we would switch the signs, right, Taylor? Yeah, let's stop talking, please. All right. So then you would bring these down. This is plus 10x. This is minus 9. All right. So we're looking here. You're still thinking like this is on top of this. This is negative 6x squared. Negative 8 minus 1 is negative 9x. You're still thinking in the same way. And if it's helpful for you, write it down on a piece of paper. 9 minus 13 is negative 4. What's nice is they gave you multiple choice, right? Negative 1 minus 8 is negative 9. Negative 11 plus 9 is negative 2. 4 minus 7 is negative 3. All right? Then, I think you have to take the opposite. So you're really thinking negative 3 minus 2. 4 minus 6. And this, since we're subtracting a negative, we're really adding 10. So negative 12 plus 10. So you got to pay attention to your signs. You got to pay attention to what you can combine with them. So negative 4 minus 9. Negative 9 plus 1. 1 plus 8 here. All right. So that's all you had to do yesterday. So make sure you go back and get those done. I felt like it was good review. All right. Today we're going to start a little bit something new, but I'm going to give you about 5 more minutes for those of you enthralled in your boom decks. But if you have your phone out, I'm probably going to take it. I don't really know why there's any need for a phone right now. All right. Let's pause the recording. I don't need credit for this assignment, but you do. All right. The next part in our workbook assumes that you know what factors are, and common factors, and greatest common factors. So we need to review that so that if you've forgotten, you'll remember, right? So factors are numbers that multiply together. I'm asking you the last time to go have a seat, Landon. I've asked you 4 times to please sit down. Allison, not helpful. So the two numbers that multiply together to make another number are factors. You're staring at your Chromebook right now. You should have it closed. If you've got your phone out, it should be off and put away. Close your Chromebooks. Put your phones away. Don't want to see them. Put them away. Away, away. All right. So I always start like I'm counting. I asked myself, can I multiply 1 times something to get 32? What? 1 times what? 1, excellent. So I'm going to put my 32 here because that is my biggest factor. Then I keep counting. What comes after 1? 2. Can 2 go into 32? Yes. 2 times what is 32? 16. So I'm putting a 16 out here. What comes after 2? 3. Can 3 go into 32? No. Well, 3 times 11 is 33, but that's not 32, so there's no way, right? What comes after 3? 4. Can 4 go into 32? 4 times what? 8. All right, we're going to keep counting after 4. What comes after 4? 5. It doesn't end in a 0 or a 5, so that doesn't work. 6? 6 won't work. 6 times 6 is 36. That's about as close as it gets. All right, what about 7? And here I am at 8, so I can stop here. This is it. Landon, I need you to go. Take your stuff with you. Landon, come here, please. Grab your stuff. I want you to walk to Mr. Perrin's room, and you can sit in there and do it. Nope, you need to go to Mr. Perrin's room. To the right. Okay. All right, here's what we're going to do. We're going to list the factors of 40 the same way. Stay with me. I'm counting still. 1 times what? What comes after 1? Does 2 go into 40? 2 times what? Excellent. Does 3? No. Does 4? So I'm going to write 4 down. 4 times what? How about 5? Yeah, good job. 5 times 8? How about 6? 7? And we're at 8. So that means we are done. Now, anything, guys, listen. Circle the common factors. So they have 1 in common, 2 in common, 4 in common, and 8 in common. Anything else? So in the middle here, I'm going to write 1, 2, 4, and 8. Now I'm going to look at the top at what's not circled, and I just have a 16 and a 32. If I look at the bottom of what's not circled, I have a 5, a 10, a 20, and a 40. All right, are you listening? The greatest of the common factors is called the greatest common factor. Whoa. Pretty obvious, right? Wow. So using your list or Venn diagram above, what's the greatest common factor? What's the greatest one in the middle? What is it? 8. It's got to be one in the middle, right? All right. So you can do these 2 ways. You can make lists. You can make Venn diagrams. I prefer the list method just because it helps. But I'm I'm going to list the factors of 60 and the factors of 36. What's nice is after a while, we might have some repeat numbers and we can look back at our work and compare them, right? But not yet. So 1 times what makes 60? Does 2? It's definitely even. 2 times 30. 3 times, there's a lot of factors. 20. If you're not sure, you could take 60 and divide it by 3. You could take 60 and divide it by 4. You can use a calculator for this if you need to. 4 times what is 60? Put it into your calculator quickly. 60 divided by 4. Come on, guys. 15. 5 times what is 60? 12. We're running out of room here. 6 times 10. So there's nothing after 7. There's nothing between 10 and 12 that works. So that's a lot, but that's it. Yeah. It says you either need to use factor lists or Venn diagram. So do you need to write it all down? Yeah. I do know like the first. All right, 36. 1 times 36. Does 2 go in? 36 divided by 2 is 18. 36 divided by 3 is 12. 36 divided by 4 is 9. 5 doesn't work. 6 divided by 6, I'm sorry, 36 divided by 6 is 6. 6 times 6, that's a square. Which one's the biggest one they have in common? 4. They also have 6 in common, and they also have 12 in common. So what's the greatest common factor? 12. All right, so we're not going to stop. We're going to keep writing down our problem. We know we have to list our factors. Yes. Hurry up. 1 times 15. Can we divide 15 by 2? Can we divide it by 3? Good. And then can we divide it by 4? And then we're at 5. So we're done. That's it. Here's the question. Can we divide 45 by 15? Yeah, so that's going to be our biggest one. So this would be 1 and 45. 2 won't work. 3 times, there's the 15. So that's going to be your biggest one. 4 doesn't work. 5 times 9. All right, 27 and 63. 27 doesn't have too many factors, I don't think. 1 and 27. 2 doesn't work, but 3 does. 3 times 9. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. And then we'll get to 9. So that's it. So can we divide 63 by 27? No, but can we divide it by 9? Yes, so that's going to be our biggest one. If you need to prove it, 1 times 63, 2 doesn't work. 3 times, remember, just say 61 divided by 3, right? 4, does 4 go to 63? No. 5, no. 6, no. 7, yes. 7 times 9 is 63. And 8 doesn't work, so that's it. All right, these are pretty quick too. 1 times 9, 2 doesn't work, 3 doesn't, 3 does work. 3 times 3, right? That's it. 16, we have 1 and 16. What's 16 divided by 2? 8. What's 16 divided by 3? It's something with a decimal, so we're skipping 3. What's 16 divided by 4? 4. That is another square. So what's the largest they have in common? 1. If you're looking at a fraction and you're simplifying it, if the greatest common factor of your numerator and denominator is 1, that's as simplified as it gets. All right, look at these variables. Now we're going to start looking about what else we could divide them by. We could divide them both by 2, and we could divide them both by A, right? We could take A out, so we would literally have 2A. If we think of this, we could have 2, 1, 2, 3, 6, and A. Those are all our factors. If we look at this, we would just have 1, 2, and A. Since they have 2 and a letter in common, we can take both of those factors out. So if we're looking at 18, we can think 1 and 18, 2 and 9, 3 and 6. And it's also being multiplied by C, right? And then if we're looking at 27, we have 1 and 27, and 3 and 9, but we also have a C. So now we have 9, and we both have a C, so we have 9C. Can we take anything? Can we divide the 9 and the 10 by anything besides 1? Not XY, because this doesn't have a Y in it. It would just be X. So if we were listing these factors, we'd have 1, 3, 9, and X. Here we'd have 1, 2, 5, 10, X, and Y. So if we just have a 1 and an X, we just have 1X, which is X. All right. What do you think 8 is? What's the greatest common factor of 25X and 50X? Good. Good. 25 times X times 2 would be 50X. How about number 9? Not 3. I can't divide 5 by 3, but I can divide it by 5. And this has an X in it, this has a Y in it. They don't have the same variable in them, so I can't take any variables out. Same with the next one. What is the greatest common factor of these two? Very good. 1. That's it. We're done with the front side. Any questions thus far? All right. This is your riddle to solve. You've got about 20-ish minutes or so. All right, try this. Try it. Use what we just learned. Start listing your factors.